All right, our last little bit of naming that we're going to do is naming molecular compounds. So when you are naming molecular compounds, you need to use the Greek prefixes. All right, these are your Greek prefixes that you'll find in a table 5.1 in your book. Okay, so molecular compounds are when two or more nonmetals put together. And in order to name them, we're going to use the Greek naming system, so therefore you have to memorize these prefixes. Mono is 1, di 2, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Okay. Many times mono is omitted if you just have one element, like carbon monoxide, but that's one of the only cases that you will use mono. All right, so I'm going to show you how we're going to name these. All right, so here are a couple of examples of molecular compounds. These guys are all on the right-hand side of the periodic table, and they are nonmetals. This is phosphorus and oxygen. Okay, so when you guys are using the Greek naming system, you're going to use the Greek prefix for how many of each of the elements that you have. So I have 2 phosphoruses, so this would be diphosphorus, and then this would be pentoxide. Okay, this is sulfur and fluorine. Okay, and we have 1 sulfur, so we don't normally say mono, so it's just sulfur. And then we have 6 fluorines, so it would be hexa. And then for the second element, it's always the element stem name plus ide. Okay, just like in the previous one, it was pent and then oxide, and then the first element is the whole entire name. All right, so here we have sulfur, and then hexa, and fluoride. Okay, so the first element is the full name, and the second one is the element stem name plus IDE. Let's try this one here. This is silicon. We have 1 silicon, and then this is bromide. Okay, so we have 4 of them. So we're going to use the full element name for the first element. So silicon. And tetra. Bromide. All right, perfect. All right, now let's try to go the other direction. Dichlorine pentoxide. That means that I have 2 chlorines and I have 5 oxygens. So how would I write the formula? Cl2, showing the di, there's 2 of them, and then there's 5 oxygens. So O5. I actually really like naming these. I think they're super easy. Okay, tetraphosphorus hexasulfide. Okay, that means I have 4 phosphoruses and I have 6 sulfides. So that is going to be P with a 4, showing that there's 4 of them, and S with a 6, showing that there's 6 of them. Okay. All right. Now, next I want to tell you about naming acids. You guys have a list of acids in your book, and there are ways to name them, but it really is better if you just recognize the acids. You can recognize them because they have the H's out in front. Here is a list of acids in table 5.6 of your book. These are common that you should just recognize, and like I say, there are ways to name them, but it's easier just to memorize them because there aren't too many. You can recognize them because they have an H out in front, and go from there. I suggest flashcards. All right, here's a map of everything that we have done. It actually looks a lot more complicated than it is until you get to the acids. For naming ionic compounds, it explains exactly what path you need to take. For naming molecular compounds, it explains the path that you need to take. And then here are the rules for naming acids. Like I say, I always just suggest memorizing the acids. So this is a table in your book that you guys are able to use as a resource if you get lost. All right, the last thing for this chapter is the formula mass, and this is the mass of a molecule or formula unit. For any compound, the formula mass is the sum of all of the atomic masses of all of the atoms in the chemical formula. So the atomic masses are listed on the periodic table, okay? So you're going to take the number of the atoms. So if it's sodium, you're going to get the atomic mass of sodium. And then say we're doing chlorine as well, you would get the atomic mass of chlorine. So let's say Na and Cl. You get the atomic mass of each of those, and then the sum of those would be your formula mass. Okay, if I have, say, H2O, so H2 and O, I would get the atomic mass of hydrogen times 2 and add it to the atomic mass of 1 oxygen. All right, so you guys can try that on your own, and that is the end of this section. Great job.